Perfect. Thank you very much. I'm going to just get started as people are walking in and out, because this is a huge talk, more than you ever wanted to know about resource hints. And I promise you, it probably is more than you ever wanted to know about resource hints. I think we're looking at 158 slides, so strap yourselves in. Don't expect to leave this talk inspired. It's just wall-to-wall facts, weird things, bugs, quirks with resource hints, all about making websites faster. My name is Harry. I'm a consultant performance engineer from England, which explains the weird accent. But what was quite nice is I am from England. It was great that you put on a bit of English weather for me. I was expecting some Croatian weather, but I got some nice English rain the last few days, so feeling at home. As mentioned, real briefly, I won't cover this in too much detail, but I do tend to work with pretty large clients. I help clients like these make their websites faster, because faster websites are good news for everybody involved. Now, clients of this kind of size and scale normally require quite long-term engagements, quite a lot of input. But what I thought I would do today is give a talk where we can cover some of the most simple, effective, and basic kind of performance improvements that we can achieve within minutes, right? Not weeks, not months, but literally in minutes. I'm also a member of something called Google Developer Experts. It's a thing that any developer can become a part of. So if you're interested in this, find me during one of the breaks. During this talk, we will see slides that look like this. Any slide that looks like this is going to be a quick takeaway, a little summary, something just to kind of try and memorize, right? Just remember that one bit, and it will summarize the entire section. If you see a slide that looks like this, pay particular attention. This is going to be a caveat or a bug or a regression or a warning, something that could go wrong if you're not careful. And if you see a slide like this, you notice the bottom right-hand corner is a little icon of a camera. It might make it a little easier just to have your phone ready, snap a photograph of that particular slide, and you can just reference that while I'm speaking through the next part of that section. So, resource hints. Who's heard of resource hints? Okay, I'd say maybe 20 of us. Of that 20, who's used them? Who's used resource hints in production? Fewer, maybe like 8 to 12 of us. Perfect. By the end of this talk, we will all be resource hint experts. The spec describes them as primitives that enable the developer to assist the user agent in the decision process of which origins it should connect to and which resources it should fetch and pre-process to improve page performance. My God, that is boring. Basically, in more human terms, we're looking at single lines of HTML that can dramatically speed up your website. And I'm not kidding, it really is single lines of HTML. These are single declarative link rel equals tags that go in your head of your document. We will get a little bit more advanced later on, but really this is kind of as basic as we're talking. These single lines of HTML can make tremendous differences to the speeds of your applications. As always, I would recommend reading the specification in full. The specification's available right there. But the whole point of this talk is that you shouldn't need to read the spec by the end of it. I'm going to distill all the good bits, all the weird bits, and all the important bits so that the spec kind of becomes almost obsolete. One thing I'm really keen to point out is the word hints. There's a reason that these are called resource hints. That's because the browser can choose to ignore them. These are things that we tell the browser, hey, if you get enough spare time, if your CPU dies down enough, if the network goes idle for a long enough time, consider doing this bit of work up front. So all of these things, the browser will use its own heuristics, its own metrics to determine whether or not it will actually conduct these things. So then it makes them very, very safe. It means that the browser will make its own informed decision about whether to execute these or not, because there are scenarios in which executing these hints could actually make the web page slower, and the browser will therefore choose not to do them in order to preserve current page performance. We're going to look at, I've got one missing from here, unfortunately. We're going to be looking at 6 resource hints. The first 2, DNS prefetch and preconnect, these deal with visiting third-party domains. We would use these if we know that our page or our application needs to visit a third-party domain. We would tell the browser about that early. The next several, so prefetch, preload, there should be a number 5, a different number 5 should be subresource, and prerender should be number 6. These are all resource hints that we use if we know about files that we're going to need later on. So the first 2 are all about domains that we know about, that we need to go to at some point. The last three, but four in the actual full talk, they're all about getting files that we will need later on, but getting them ahead of time. And what we'll actually find is that Prerender, number 5, it goes even further. Prerender deals with entire web pages that we might need later in a session that we can download and build ahead of time. So let's start at the beginning. The simplest and most basic of all the resource hints is DNS prefetch. DNS prefetch basically tells the browser to resolve the IP address of a given domain ahead of time. So this is a useful resource hint to use if you know that your page will visit a certain domain, perhaps twitter.com, or you might link to something from Google Fonts, but you don't necessarily know the exact URL for the file that you will need. The syntax is incredibly simple. It is declarative. It's just link rel equals DNS prefetch, and what you will notice in the href is just simply a domain. This is the domain that our page will later visit. Support is pretty good. It sits at 81%, so this is absolutely something we should be using immediately. But what would we use it for? I think one of the most compelling examples is an example directly from my own website. I have a page on which I've embedded a YouTube video. Now, the browser doesn't know that it needs to visit youtube.com until it parses line 155. And as the browser is completely synchronous, it has to parse lines 1 to 154 before it can find that reference. That's way too late, because the browser needs to work out where youtube.com even lives. In order to download this file, this embedded video, we've got to do a series of steps. And the first one is working out what the IP address is for youtube.com. That involves a DNS lookup. DNS, simply swapping out a domain for its IP address equivalent, can be quite an involved process. When I was researching how much time we're saving, the numbers vary quite wildly. Common names can answer in closer to 80 to 100 milliseconds. Less common names can average 200 to 300 milliseconds, right, just to work out the IP address for a domain name. But when you start to get into sort of hairier territory, maybe a brand new domain that hasn't propagated around the internet yet, or perhaps you're on a very high latency connection, that can get much more severe. Interestingly, for any of these queries that access the internet, have dropped packets or overworked resolvers, this could increase or regularly increase resolution time between 1 and 10 seconds just to work out the IP address of this domain. That's far too much time. And unfortunately, we're dealing with a sliding scale of anywhere between 80 and 10,000 milliseconds. What resource hints allow us to do is pay this cost up front, hide it from the user. This is a screenshot from a friend of mine, Andy Davies. Him and I work together on performance projects. What you'll notice here is all of these arrows are pointing to DNS lookups that are divorced from the rest of the file's download. Not by much, but we're starting to save tens and potentially hundreds of milliseconds in the right scenarios by using these resource hints. We're doing the DNS lookup before we need to do the rest of the work. DNS prefetch is the simplest. It's also probably the least effective, and there is also a weird bug. In IE9, if you still have to support IE9 sympathies, they implemented DNS prefetch as prefetch, so the name is completely different in IE9. This doesn't seem too bad right now, but what will happen is we'll come back to this later. When we start to look at what prefetch is meant to be, they're basically the opposite behaviors in IE9. We'll come back to that in a bit. So DNS prefetch is all well and good, but it's quite light touch. It doesn't really give us that much power. Simply resolving an IP address can save tens to potentially hundreds of milliseconds. Therefore, the next and slightly more powerful resource hint we should look at is preconnect. Because what preconnect will do is it will also look up the DNS, or the IP address, but it will then step through to do a TCP handshake and conduct TLS negotiation if that's a secure connection. So it'll open up a fully fledged TCP connection to an external domain. This is particularly useful if you've got critical third-party domains needed to build your page. For example, Google Fonts. If you need to go to Google Fonts, you can tell the browser to, ahead of time, open a fully fledged TCP connection to that domain and save that cost up front. So again, you would use preconnect when you are aware vaguely of the domain, but you don't necessarily know the entire file path of the file that you need. The syntax looks very familiar. We're just swapping out DNS prefetch for preconnect, and this time we are going to Google Fonts. Browser support for this is actually better than DNS prefetch, despite DNS prefetch being older. We're currently looking around 84% global support for this resource hint. And what this resource hint is going to do is it's going to go ahead and not only do the DNS, but it will step forward and do TCP and TLS. Now, this diagram is stolen straight from my favorite book. The book is freely available, completely free at hpbn.co, highperformancebrowsernetworking.co. This is the work involved in opening a secure TCP connection. This diagram doesn't even show us the amount of time spent on DNS. What we're going to see here is that we're spending, in favorable conditions, around 56 milliseconds doing a TCP handshake. Once that handshake is completed, we then have to do a further 112 milliseconds to negotiate a secure connection. This means we've lost 168 milliseconds just like that in order to get hold of, or in order to even request a file. 168 milliseconds might not sound like a lot of time, but I worked with a client last year. They found out that if they could improve performance by 300 milliseconds, they would make an extra £8.1 million every year. If we can save just over half of that with one line of HTML, that's pretty worth it. I didn't tell them what I actually did for them, because they would never have paid my invoice if I'd have said, it's going to cost you 10 grand and you got one line of HTML for it. Never tell your clients what you actually do. This is my site before I implemented Preconnect. You can see that all of these files here, I'm doing DNS, TCP, TLS immediately before I need that file. This is very inopportune. This is very inefficient. By adding a handful of lines of HTML to my head tags, I managed to pay that cost up front, completely divorce the network negotiation cost from the file download. Basically, I'm paying all my latency up front and hiding it completely from the user. If you want to support as many browsers as possible, you could use Preconnect with a DNS prefetch fallback, so use both of them. The nicer syntax to use would be this. This is completely valid HTML. The rel attribute is allowed to have more than one value, but unfortunately, this just plain will not work in Safari. I made a little test case. By using the concatenated two values in one rel, this just stopped working. You can see on line 2 here, the DNS TCP TLS is now attached back to the file. This is a temporary issue. There's a bug open against WebKit. My friend Andy Davies opened this bug, so it should be resolved. But in the meantime, if you want to hit ultimate browser support, it's simply a case of doing this. It's a little bit of duplication, but that will capture newer and older browsers, falling back to just doing DNS in browsers that don't support Preconnect. Interesting things with Preconnect then. Be judicious. Be careful. Don't go and Preconnect a million different domains. In fact, a good rule of thumb is that if you've got 50 Preconnects in your head tags, you're probably using too many third parties. So that's a good litmus test for you to work out if you're going a bit crazy with the amount of third parties you're using in the first place. But Preconnect is kind of interesting. I would recommend only warming up frequent and significant and likely to be used origins. That's things like Google Analytics used on every page, Google Font used on every page. The next thing, don't warm up fourth and fifth and sixth party origins. If you've got a third party that has its own third party, don't warm their third parties up, because if that third party of yours stops using that provider, you're wasting TCP connections. Another thing as well is CPU cycles and battery will be reduced if you have too many open connections. Maintaining open TCP connections on both a client and server will have sort of, maybe not huge, but certainly tangible CPU and battery cost. I'm going to be kind to the Chrome team. I'm not going to tell you exactly the full story about the last bullet point on here, but if you buy me a beer, or some Slivovitz actually, get me a shot, I will tell you about a very, very, very weird bug in Chrome, which means Chrome is only allowed to ever do 6 TCP connections DNS resolutions, at once. Very weird bug. One of those bugs that's so weird you can hardly believe it. But if you find me after the talk, I will tell you what it is. So you can only do 6 DNS resolutions at a time in Chrome. Bad news, we're kind of Firefoxed. Firefox is just completely broken. It stopped working in Firefox 66. So if you start trying to implement Preconnect in Firefox 66, and it doesn't appear to be working, it's simply a regression. It disappeared, it will be coming back, it just stopped working. So 66, nothing to worry about too much. It will be repaired soon. But if you're debugging in that browser, it will not be working. So those two resource hints, they both deal with warming up domains, right? Going to external origins. This is useful if we don't know what file we need or if we need several files from that domain. If we're in a situation where we are lucky enough to know what file we will need, what exact URL, we can begin to use some different resource hints. The first one of these is prefetch. Prefetch is really powerful. If anybody's building a single-page app, for example, and you're doing sort of route-based splitting, prefetch will be really powerful for you there. If you're building an e-commerce site and you happen to know very strict user journeys, especially through perhaps the checkout flow, prefetch will be very useful for you there as well. Prefetch is a resource hint that will download a file needed for subsequent navigation. I find this really interesting, that the wording of this is directly from the specification. They don't say it's a file needed for the next page. They're like lawyers. They're very clever with their wording. What they've said here is subsequent navigation. Subsequent means that it doesn't have to be the next page that your user goes to. It could be a page in 10 views time, right? So it's not the next page, it's a subsequent page. And the reason they say navigation instead of page is that that means this has to work with a single-page app. With a single-page app, you don't have pages, you have routes or views. So what this means is that prefetch has to work in a single-page app environment. Syntax, again, very, very familiar. Rel equals prefetch, but this time you'll notice we're pointing to a specific file. Right? We're not pointing to a domain, we're pointing to a specific asset. Browser support for this is pretty good, 82%, so again, absolutely we should start using it. And I think one of the really compelling or one of the best examples of when to use prefetch would be, imagine if we worked for YouTube. It'd be a pretty cool job, and we've just built the search results page. Somebody's just searched for cute cat videos, and we are 90% certain, 95% certain, they're going to click on one of those thumbnails and go through to the next page. On the next page, they're going to need some JavaScript to run and use this video player. Knowing that, as developers, we can be clever. And we can actually tell the search results page to download that video player JavaScript ahead of time. So that by the time they click through to watch the video, the browser doesn't have to go back across the network. It's already downloaded from the previous page the file that it needs to run the video player. So it will simply download the file and drop it into HTTP cache for later usage. So this is where things get interesting. The user agent should not apply pre-processing on the response and must not automatically execute or apply it against the current page context. This makes prefetch very, very safe. Prefetch is simply a stateless, inert download. Your prefetch will download the asset, but it won't be executed until the application or require.js or a script tag is what actually invokes it. So it's very, very safe. It downloads it, stores it in browser cache, ready for later use. Yeah, it will store it in cache for later use, except if the caching headers say you're not allowed to. So what prefetch will do is it will make sure the caching headers allow the file to be cached. And if the file gets older than 5 minutes, whether it's cacheable or not, if the file ends up going over a 5-minute threshold, it will get revalidated. That 5 minutes seems very arbitrary. It was just decided by Chrome developers that 5 minutes is a good cutoff point. So even if the file's cacheable for a year, it will get revalidated after 5 minutes. So don't prefetch too soon in advance, because there's a chance it will get revalidated anyway. Prefetch is pretty smart. The file is fetched with the lowest possible priority. What this means is that after everything else has died down, usually the load event has fired, the browser will then go back to the head tags and start doing your prefetches. This means that the prefetched videoplayer.js or whatever the file is, it will not interrupt the loading or the building of the current page. I had an interesting thought a while ago. What happens if page A begins downloading, prefetching a huge file, and you click away from page A onto page B before that prefetch has finished downloading? Does the browser continue the prefetch in the background, or does the browser cancel it and then just sort of delete the half-downloaded file? Turns out the browser is pretty smart. So if page A begins a prefetch, and we navigate to page B, that prefetch will persist. So the download will finish. The browser will still use that file if necessary. What it won't do is it won't cancel a prefetch, and it won't double download any files. This is impossible to find out through DevTools, because DevTools can't show you what's happening. So it took me a long time to work this out. But basically, prefetch will persist across navigations. The bad news, if you're using IE9, anybody using or having to build for IE9? Just me. I work for UK government a lot, and we're going to do IE8. That's why I look so sad. Prefetch acts like DNS prefetch in IE9 because typical browser vendors didn't speak to each other. In IE9, DNS prefetch is actually called prefetch. So if you try and use prefetch in IE9, what you will actually get is DNS prefetch. It will just look up the DNS for this domain. IE9's dead, we don't care about it, but if you have to support it, just be aware that prefetches will work a little differently. Can we nudge my slides somehow? I think the connection's good this end. No, it's back. The next one is preload. Now, if prefetch is downloading a file needed for subsequent navigation, preload is an immediate mandatory fetch for a file needed for the same navigation, for the current page. This is where things diverge a little bit. So preload used to be part of the resource hint specification, because as I said before, resource hints are hints. The browser doesn't have to do them. That changed perhaps a couple of years ago when it was decided that preload is now mandatory. So it has its own specification. It has a separate spec, because if you give a browser a preload directive, it has to do it. The spec describes it as a mandatory fetch for a file needed for current navigation. And it's basically a good way for developers to surface late discovered resources. I'll come back to what I mean by a late discovered resource shortly, but the syntax starts to look a little bit different now. The top line should look familiar. We've got a rel, but this time it's preload. We've got a path to a file. But this bottom line is where things start to look a little bit different. We have an as attribute, which sets the type of file we're downloading. Or not the type, but the classification. We have the type attribute, which optionally specifies the MIME type. We've also got the optional cross-origin attribute in case we need to fetch credentialed resources. Support for this sits around 79% globally, so it's pretty good, definitely worth using. But there are some pretty severe bugs in Chrome that I will talk you through in a second. But first, let's discuss this. What's a late discovered resource? What does that mean? Certain types of file, by virtue of how they are loaded, are what we would call late discovered resources. A font is a really good example of this. In order to download a web font, we have to download some HTML, which then needs parsing. That will reference some CSS, which needs downloading and parsing. Then the render tree gets built. Then at that point, the browser thinks, oh my goodness, this heading needs to be in Open Sans. And the browser has to go back and get the font. A font is a late discovered resource. Same with the background image. This background image, we're spending 1,250 milliseconds on this thing because the background is bigger than a web font. So we're losing time here because of this late discovered resource. Show of hands, who is building a fully client-rendered JavaScript application? Who's working on SPA? Who's working on a JavaScript app? Don't be shy. OK, a few of you. Unfortunately, client-rendered SPAs make this a lot worse. With an SPA, traditionally, if you're going full client-rendered, you've got HTML, then JavaScript, which needs to build your virtual DOM. Then your virtual DOM may inject some link rel equals style sheets or some style tags. Then that CSS gets parsed, and then we find the font. And now we've gone up to 1,350 milliseconds to get text beginning to render. The good news is preload is designed to help with this. Preload helps the browser find them sooner. So if we're building a single-page application, we just change our code to look a bit like this. Go and grab app.js, but then let's preload our style sheet, and let's preload the web font. Now the network stack, or sort of the network request waterfall, looks like this, achieving maximum parallelization, and we just collapse this way down to 3/4 of a second by adding 2 lines of HTML. Quickly looking at the attributes we have available, we've got the as attribute. Now, the as attribute used to be optional. It used to be completely optional, but has since become mandatory. So if you have implemented preload in the last couple of years, you may need to check now that you're not getting errors because the as attribute recently became mandatory. You can't decide or invent a value for the as attribute. It has to be one of these. And the as attribute is really powerful. What it will do is it will guarantee correct prioritization. It will ensure that the browser treats the preloads with the correct priority. A font is more important than an image. A style sheet is more important than a font. A script is less important than a style sheet, but more important than a font. So the browser needs to know what order to execute these things in. It will also ensure the correct request matching. It will ensure that the correct CSP policy is set. It will also do things like issue the correct request headers. So what that means is if you were to try and preload as equals image, it won't tell the server to try and gzip that image, because that wouldn't make any sense. You can see here 3 preloads for different types of files, and all the priorities match the natural priority of that file type. So as I said before, style, highest priority, script, high priority, images, low priority. This allows the browser and server to work in tandem to deliver these assets as fast as possible. I can guarantee at least 5 of you have just had the same thought. Well, what if I was to do my preloads, but then kind of start with this and change it to this? Because every developer wants to be a hacker, really, right? I would not recommend doing this. This will go badly wrong. I've had a lot of people ask me, well, can I trick the browser into downloading an image with a script's worth of priority? You can't, is the short answer. Things will kind of blow up. What you'll notice here is we've now doubled all of the downloads for these assets. We've made things roughly twice as bad. The priorities were initially misset, and then were reset correctly, and everything was downloaded a second time. So you can't actually manipulate the priorities by using the as attribute. However, what you can do, definitely take a picture of this slide. There's a new specification that's not live in any browser yet called priority hints. Priority hints will help us with this. So with a priority hint, we can do importance equals high, importance equals low. Who's heard of priority hints? Anyone seen this yet? Perfect, just me. Well, all of you now, right? This is a new attribute. It's landed in Chrome Canary. It's behind a flag. But this will be available on link rel equals. It'll be available on script elements. It'll be available on image elements, iframes. This allows you to communicate to the server how important you feel an asset is. Oh, right, the type attribute. The type attribute on a preload is optional, but it can be very useful in certain scenarios where you might have contradictory resources. What I mean by that is, if we take Safari, for example, Safari does support preload, but Safari doesn't support WebP. You can't proxy a file type from its file extension. That would be a huge security flaw. That would be a bad idea. So the browser can't look at the .webp and work out what file type this is. Without the type attribute here, what would happen is Safari would download this file and then realize it can't do anything with it. So optionally, we can provide the MIME type of that file so the browser decides whether to initiate the preload or not. The final attribute we have is also optional. It's the cross-origin attribute. Who's got a pretty good understanding of cause? I'm very jealous of you because I don't, right? I've read it so many times, I still can't quite work out what it is. Preload links for cause-enabled resources such as fonts or images with a cross-origin attribute, blah, 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 blah. If you're fetching a credentialed resource from a different origin, you may need to pass in the cross-origin attribute. If, like me, you don't fully understand the exact rules of when this happens, my advice is very, very simple. Keep it on console. Specifically in Chrome's developer tools, the console gives you really nice guidance about how to correctly implement preload. I created a page where I just got everything wrong. First thing I did is I missed out the as attribute, so the preload wasn't initiated, and I got a warning. The second error, I actually preloaded a file that wasn't needed. I see this a lot of times in client work. They will try and use a preload, and the file wasn't even necessary. So Chrome will tell you that, look, you wasted some bandwidth on a file that never even got used. And finally, I misset, or rather didn't set, the cross-origin attribute for a font, and the browser gave me an error. Sounds pretty cool, right? Yeah, well, I guess that wasn't a question. I'm telling you, this is pretty cool, until you realize that Chrome isn't very good at this. I feel really bad because Chrome is a wonderful browser, but it's really kind of tripping up when it comes to preload. What Chrome will do is it'll over-prioritize preloads, and preloaded files are needed sometime soon on the current page, not immediately. What happens in Chrome is these files will steal bandwidth from files that are needed immediately. They get over-prioritized, and they steal resources from more important files. It will dispatch the requests before critical resources and often return the responses before critical resources, in effect stealing bandwidth. Here's a web page, again, by my buddy Andy Davies, where he hasn't implemented preload yet. He hasn't implemented it. If you look at entries 2 through to 6, you'll see lots of style sheets. And one of these style sheets is going to request a web font. And the web font is, I'm going to guess, around here somewhere. Right? It's off the screen. In order to make this text render quicker, a lot of advice would tell you, preload the font. Grab the font from preload. So we did. We put a link rel equals preload in the head tags. Something bad happened. The fonts are now requested immediately. They're the very first things to get requested. They are over-prioritized. But the bad news here is all of those fonts arrive before the first style sheet does. The painful irony here is that a font is useless without the CSS to apply it to the page. These fonts have stolen resources from the server and the network. The fonts have arrived before the style sheet. This website got slower. This website actually got 400 milliseconds slower by using a feature that was meant to make it faster. It's kind of a scary kind of word of warning, but if you are going to implement preload, please run waterfall charts in Chrome and double check that it isn't broken. Chrome engineers are fixing it quite actively. They are working on it. But just be careful when using preload in Chrome. The next resource hint we're going to look at starts to stray into different territory. This is the one that I forgot to mention in the table of contents earlier. Subresource is an interesting one. We will learn a bit more about its kind of backstory. But subresource was actually the precursor to preload. So we've got preload now, but before then we had subresource. But it's completely deprecated. If you use it, it won't work. It's just completely deprecated and no longer supported, because subresource is a bad idea. Basically, subresource used to do everything that preload did, but then none of the extra bits, none of the good bits. A subresource would look like this. You'll notice that we're missing as attributes, we're missing cross-origin, we're missing type attributes. Subresource is very insecure, and it wasn't very useful. So they killed it. RIP subresource. A friend of mine, a Chrome engineer called Yoav Weiss, he had this to say at subresource's funeral. It was not useful, it was proprietary, and it was buggy. It's a hell of a eulogy, right? I hope no one says that at my funeral. Unfortunately, subresource didn't have any of the security protections, didn't have any of the as attribute to do request matching, didn't have any of the CSP policy stuff. So subresource was simply killed. If you see it in the wild, it won't work, just delete it. The final resource hint we're going to look at is kind of the final boss. This is the big one. This is the one that goes way off-piste. The first 2 did domains. The next 3 did specific files. What Prerender now does is entire pages. With Prerender, you can instruct the browser, hey, go and grab this web page, download it in an invisible tab, start building it, so that by the time a user clicks through to that page, it's already on the device, it's built, it's rendered, it's finished. Kind of. This is a bit of a complicated story. Prerender had a very interesting history. A bit of a roller coaster. It gets you really excited, and then you realize, oh, it doesn't work, but then it kind of works again. The syntax was really, really simple. So we're going back to the simplest syntax of all, a rel and an href. This href points to a page. That's the primary difference. Support's 71%. And I think a really telling, really kind of interesting bit of insight you can get from this screenshot is that Prerender was such a bad idea that the IE11 team decided not to port it over to Edge at all. It never made it into Edge. It was just killed off. Chrome, you can't see on this screenshot, but it disappeared from Chrome for a while, so it kind of disappeared and it was reintroduced. So let's look at a use case for Prerender. Remember earlier we talked about if we're building youtube.com and we click through to the next page. Before we were just downloading videoplayer.js, right? Well, now the opportunity we've got is we could look at our analytics for youtube.com and we could work out 75% of people will click on the first thumbnail. So let's do a link rel equals pre-render for that first thumbnail here and render the entire page in the background. But it was a bad idea, so they killed it. I've only just realized that pre-render and sub-resource are in the same grave, which is pretty morbid. I should have got a different grave for both of them. It's kind of gross. This graveyard's getting full as well. OK, think about these problems, right? If pre-render takes a web page and renders it in a hidden tab in the background the user doesn't know about, think of all the ways that could go wrong. What if a developer goes crazy and decides to pre-render 25 pages? It's a huge memory footprint. It's a huge network usage. If that user is on a data roaming plan, they're trying to view one web page, but they've just downloaded 7 in the background, it's going to get expensive. It'll register multiple analytics hits. So if you've actually got a page being built in the background, fully rendered, your analytics kicks in. All of a sudden, your site looks like it's got 4 times as much traffic. That's not great. However, if you're running ads, you've got 4 times as many ad impressions, so I guess that's pretty good. How do we handle things like HTTP auth, or timers that count down, or interstitials, or cookie notice warnings? If the page is hidden in a tab that the user can't see yet, how do we handle all this stuff? How do we handle animations? Do we wait for page visibility to run animations, or should the animations run in the background tab hidden from the user? The biggest one of all, for me the scariest one, is if you've got a page that's insecure and it's using a pre-render, if that page gets man-in-the-middled and somebody changes the pre-render to point to a crypto mining site, a user could visit an innocent web page, but unbeknown to them, in a hidden process, in a hidden tab somewhere on their device, there's a crypto mining website that's started running. And maybe it's installed a service worker, so they can't really kill it off just by closing a tab. This is exactly why they threw pre-render in the bin. Pre-render is dead. Kinda, right? They brought it back, but they called it no-state prefetch. I told you it was a bit of a wild ride. No-state prefetch is nowhere near as cool a name, very unsexy name, but it is kind of a new mechanism behind pre-render. What Chrome did is actually kind of smart. Pre-render is still the API, so the syntax you type into your HTML is still link rel equals pre-render because that gives us backward compatibility. Means that all the pre-renders that people started building years ago will still kind of work without having to update any syntax. What changes now is the mechanism inside the browser isn't pre-render anymore. It's something called no-state prefetch. That's the mechanism. What this means is that pre-render will literally not render anything, which feels a bit counterintuitive, but it was the better thing to do in terms of backward compatibility. So let's have a quick look at what no-state prefetch does. If you cast your mind back about 50 slides, when we looked at prefetch, that's you telling the browser, from this page, go and download a file that will be needed on this page. What no-state prefetch does is kind of a recursive version of that. I like to think of no-state prefetch as simply a recursive prefetch. So instead of doing prefetch for videoplayer.js, videoplayer.css, and all the different things individually, you can just pass in an entry point. So you still pass in a web page, so you might say pre-render page B. What the browser will now do is it won't render page B, it will just download all of B's sub-resources. So now what you can do is pass in this entry point to pre-render, and the browser will recursively look over that HTML and fetch any sub-resources, but will not execute anything. The fact it no longer executes things makes it very, very safe. Syntax is basically as simple as this. Link rel equals pre-render this page. It works cross-origin. It works fine. There are no security concerns because it doesn't execute any single bit of the code. Again, it's fetched with lowest possible priority so as not to interrupt the current page. And here's a very, very simplified demonstration that I made. What you can see here on line 1 is my CSS-wizardry.dev sandbox, my playground. I made a page which simply pre-renders my actual website, CSS-wizardry.com. What you'll see on line 3 is the pre-render doesn't even start until after the current page's load event has fired. So it's very, very low priority. It will not interrupt the current page. I don't have very long left. According to my timer, I've got 6 minutes. So tips, tricks, and gotchas. Let's quickly look at some little caveats, some weird things we can do. You can deploy all of these as HTTP headers. So we've looked so far at just putting them inside your head tags as a link rel equals pre-render, prefetch, preload. We can actually deploy them as headers. And what's really nice is Google Fonts do this for us for free. Every time we link to a Google Fonts style sheet, they will preemptively warm up a connection to fonts.gstatic.com for us. Really kind of them. The gains here you think might be quite marginal, but actually they can be quite huge. My friend, this guy should put me on commission. I keep mentioning him. Me and Andy worked on a project together where we deployed these as headers instead of inside our HTML. And the savings were enormous. The real-world metrics showed a 400 millisecond improvement at the median and greater than 1 second at the 95th percentile. So the average site got 400 milliseconds faster just by deploying these as HTTP headers. If you have access to the infrastructure, I would completely recommend doing this. Annoyingly, Edge only supports the header for pre-connect. If you want pre-connect to work in Edge, you have to do the HTTP header version. This really annoys me because there's a huge barrier to entry. As a front-end dev, I can type something in a head tags really easily. Me personally getting access to setting headers is going to be a lot more difficult, a much bigger barrier to entry. Conversely, Edge doesn't support the header at all for preload. So it does one only, and then only doesn't do this one. I'm not too concerned about this, so don't worry about that one too much. But that's Edge for you. This is pretty neat. You can generate all of these dynamically. You can generate these based on user input. If the user is hovering near the Add to Cart button, maybe you pre-render the checkout page for them, right? You can generate these things with JavaScript based on user input. A really good little library I would recommend experimenting with is instant.page. This is a web address. Instant page is a tiny, tiny, tiny JavaScript library, which, as you navigate a site, it will prefetch the page you're hovering over. So if we take a little look at this screencast, what we need to look at is the bottom of the head tag here. We've got a link rel equals prefetch. That was generated with JavaScript. As I hover these pages, the href gets updated. If we go and look at the network calls, we will find that the browser actually downloaded all of these pages in the background. And when I take a link to one of these pages, what we will find is that page came from browser cache, came from disk cache, and took 3 milliseconds to return it. This is a really powerful way of speeding up a navigation through your website. A couple of things to be aware of. If it's Black Friday and you're getting absolutely hammered with traffic, you need to have an escape hatch. If you've got expensive database queries at the end of every URL, prefetching that URL would go off to the server, do the database calls, build the page, and return it every time. So what you need is a thing like a feature flag, something in live, so that you can disable this without a deployment. Have some kind of feature flag in live so you can turn this off. OK, getting towards the end now, I promise. We need a scheme. We definitely need a scheme. To do a DNS resolution, technically the top one should work. We only need a domain for a DNS resolution. But because this is HTML, technically the top one is a relative file path, right? It just points to a file called domain.com on this current level. So you have to put a scheme in here. It's a simple one, but people overlook this one all the time. I am conscious of time, so what I won't do is spend too much time on this section. But if you want to put all of these together, I'll show you really quickly how to do it. By taking all of the different options we have, all the different configurations, we can begin to design really bespoke pre-browsing experiences for our clients, our customers, our users. Identify a key page, find important assets and origins. It could be video players, it could be youtube.com, it could be Google Fonts, it could be Open Sans. Assess likely user journeys. Where might the user go next? And then design a bespoke strategy around it. So here we've got a web font. That should be preloaded, right? The web font's needed for this page, but it's a late discovered resource. We've identified all these blue pages, these blue links, to be somewhere the user might go next. And let's, for example, say that all of our images are hosted on Cloudinary. That's an external origin that might need warming up. What we can do here then is, and then the next page we click through to has got a carousel.js, like image gallery. taking a page like this, looking at all the potential journeys and all the different assets and third parties we might go to, have an HTTP header to pre-connect to your image service. If it's Cloudinary or ImageX or wherever you're hosting your images, it could be an S3 bucket. Regular pre-connects for other third parties, such as Google Analytics, et cetera, et cetera. Let's have a preload to discover web fonts. Prefetch gallery.js. So if we're on the first page, download the gallery page next. I am really mindful of time, so I'm going through this a bit too quickly. There's a link to the slides on the very last slide of this talk, so don't panic too much. But putting all these together, we can design really custom pre-browsing experiences. There's how you set an HTTP header to warm up your third party for your image transformation service. Let's pre-connect other third parties, but also have a DNS prefetch fallback. Let's preload the web font that we're going to use that comes out of that style sheet. Let's prefetch the the image gallery for the next page that we view. And what we could also do is, if it's an e-commerce site, maybe we've got analytics data that shows most users will click one of the first 3 search results. Let's pre-render the first 3 search results for them, so that by the time they've clicked through, they immediately get to see all of the images, everything is downloaded, all the browser is left to do is build it. Putting it all together looks a bit like this. I'm whizzing through this far too quickly now, I apologize. And yeah, that's basically what I would recommend doing, is taking all of these options we have available and auditing key pages on your site. Could be a home page, search results page, product overview page, a logged out page. You could start pre-rendering the logged in state. I promise you I'm about to jump off stage. This guy's bigger than me. I don't really stand a chance. One thing I will say, and this is in really bad taste, who's been to Tinel Meetup before? Anyone been to this? It's like in the city. I'm speaking at that in a couple of hours, but I'm doing like a live performance audit. So if I haven't bored you enough already, I'll bore you over a beer later. Come to Tinel Meetup. That's me saying thank you very much for your patience. Thank you very much for listening. The slides are available there. Thank you.